This is the first of the old exam questions, and it's a common one. So I'll take you through how to do this. The premise is that there is a greatest integer function rule that determines the number of points you earn based on your purchase price. It says Beatrice and Maria are members. Today they each made a purchase of more than $50 at the store. I emphasize that because we're going to have to try out some different numbers. We're going to have to make sure that we meet those criteria. Beatrice says, if I pay double the price that Maria pays, I will earn twice as many points. The question is Beatrice correct or incorrect? Is the statement true or false? Spoiler alert, the answer in this type of question will always be false. You just have to find the example that proves it. So what does that mean? Well, it means that you have to try some examples. Does double the value equal double the points is what we're trying to ascertain. Remember that it said that it had to be at least $50. Not at least, actually, more than 50. So I can't pick 50. But it said that double the value, we're checking to see if that's double the points. So I want one value to be double the other one. I have to make sure that both are greater than 50. So I just picked two. I picked 60 and 120. It doesn't really matter what you pick. We're trying to find one that doesn't work. Logically, even if there are some examples that do work, to try to prove that something always works is really difficult. But if you can find one example that doesn't work, means that it doesn't always work. That's what we're trying to do here. So when I say try 60 and 120, I mean plug them in. Find f of 60. I take that same rule, I plug in 60 as the x, and I simplify. Simplifying in here, 1 over 20 times 60, sorry, negative 1 over 20 times 60 is the same as negative 60 over 20, which is negative 3. That is an integer, so it's just equal to negative 3. And when I multiply negative 3 times negative 3, that is 9 points. The person who spent double, having spent 120, works out to be negative 1 over 20 times 120 is negative 6. That is, again, an integer. So it is itself. It doesn't have to get rounded down. It's already an integer. And that's 18 points. That is double the points. So there are some examples that may work out to be double. Does that mean that it always works? No. And one way that you can test this is if you look at this here, this number when I plugged it in worked out to be an integer. This one worked out to be an integer. What I'll try next is a number where 1 is an integer and 1 isn't. So can I think of a number where one of them is not 1, if I double it, it is, or vice versa? So that's what I'm trying to think of. What I tried next, two numbers, both of which are bigger than 50, I tried 70 and 140. And I know that because I'm dividing by 20, if the number I plug in is not a multiple of 20, this will not work out to be an integer. So 70 will not be. 70 is not a multiple of 20. 140 is. It means that one of them is going to get rounded down and one won't. That might be the difference. When I plug in 70, negative 1 over 20 times 70 is negative 70 over 20, which is negative 7 over 2, which is negative 3.5. This is not an integer, so it gets rounded down. Oh, that should be negative 4, actually. That's a mistake. I'll fix that. That should be negative 4, which means this is 12 points. Okay, sorry about that. And that was a good thing to bring up, actually, because remember that when you're rounding down, you're rounding below, the lowest integer below. So that works out to be 12 points. If I tried at 140, negative 1/20 times 140 is negative 7. That is an integer. So that works out to be 21. And that is not double this amount. So I found an example that doesn't work out to be double. That means that it is not always true. And the original statement, if I go all the way back here, is this statement true or false? No, it's false. This is something that is not always true. That's how you answer a question like that.